So we've talked about how to solve quadratic equations by completing the square and by using the quadratic formula. Today we're going to talk about the third method of solving quadratic equations, which is to use factoring. Now, depending on the situation, some situations it might be easier to use factoring, some situations might be easier or require you to use the quadratic formula, and some might be easier or require you to use completing the square. So it depends on what situation you're given, how you should approach the problem. But it's good to know all three of the forms so that you can solve any of the problems that you're given. So it says to solve by factoring. So when we use factoring, okay, remember this is what we refer to as the tic-tac-toe process. So we're going to use tic-tac-toe. Hopefully everybody remembers how to do that. Or we can use our rules for special situations. So if you look at this, some of you might be able to recognize this example right here, x squared minus 36, as a difference of squares and be able to use your formula. But before we do anything, it's important to know that we cannot factor or we cannot use tic-tac-toe unless we make sure our problem equals 0 or our problem must equal y. We mentioned that when we talked about using the quadratic formula. So, since I recognize this as a difference of squares, I'm going to take the square root of the first one, take the square root of the second one, and that's going to give me x minus 6 and x plus 6 equals 0. So when we did tic-tac-toe the first time, this is where we stopped the problem. We factored it into two binomials, and then that was the end of the problem. But today we need to solve by factoring, which means we need to come up with an answer. What does x actually equal? So what you do is you break it down into your two factors, and then you take each factor, x minus 6, make it equal 0. Take the other factor, x plus 6, make it equal 0, and solve each one for x. So I'm going to add 6 to both sides. X equals 6. Over here I'm going to subtract 6 from both sides. X equals negative 6. Once you solve for x, you should come up with two answers, just like when we did completing the square and when we did quadratic formula. You're going to have two answers. X equals 6, x equals negative 6. You can check this by taking your answers, plugging it back into x, and making sure that it equals 0. Second example. 3x squared minus 10x plus 3 equals 0. So first we notice that it equals 0 so that I can go ahead and factor it. Second, I look and I realize this is not a special situation, so I have to use the tic-tac-toe here. So remember, the first thing I should look for is a GCF. 3, 10, and 3. There's no GCF, so I'm going straight to tic-tac-toe. So I draw my tic-tac-toe board. Nothing goes up here on the left. 3x squared goes here in the middle. Positive 3 goes down here on the right. I'm going to multiply those numbers together. 3x squared times 3 and get 9x squared. List your factors of 9. 1 times 9. Trying to add up to equal negative 10. That's not it. Negative 1 times negative 9. Negative 1 plus negative 9 equals negative 10. So those are the factors that I want. Negative 1 and negative 9. I put them in my two inside spots here. Negative 1x and negative 9x. Don't forget to give an x to them. Then we take the GCF of each column going up and down. 3x squared and negative 9x. The GCF is going to be 3x. Negative 1x and 3. The GCF is going to be negative 1. Remember, these two numbers right here have to have the same sign. Then we come over here and we go across and do the same thing. 3x squared and negative 1x. The GCF is going to be 1x. And negative 9x and 3. The GCF is negative 3. Remember, these two signs right here have to have the same sign. So that gives me x minus 3 and 3x minus 1 equals 0. So then we take each of our factors and we make each one equal 0. X minus 3 equals 0. 3x minus 1 equals 0. Solve each one for x. So add 3 to both sides. X equals 3. Add 1 to both sides. 3x equals 1. Divide both sides by 3. X equals 1 over 3, or 1/3. Again, you should have two answers, 3 and 1/3. You can check your answers again by taking them, plugging them back in for x at the beginning of the problem, and making sure that it equals 0. Last example, example 3. 3x squared minus 5x equals 2. If you notice, this is the first time that one of my examples has not equaled 0. So in order for me to factor this, it has to equal 0. So what I'm going to do is I'm going to subtract 2 from both sides of the problem to make my problem equal 0. 3x squared minus 5x minus 2 equals 0. 2 minus 2 is 0. So now that my problem equals 0, I can look at it. It's not a special situation. There's no GCF, so that means tic-tac-toe. So 3x squared, negative 2. Multiply them. 3x squared times negative 2, negative 6x squared. List factors that multiply to negative 6. So 1 times negative 6, adding to negative 5. 1 plus negative 6 equals negative 5. So there are my factors. Don't have to list very many. Take my factors, put them in the tic-tac-toe board. 1x, negative 6x. Find the GCF of the columns going up and down. So 3x squared and negative 6x is going to be 3x. 1x and negative 2 is going to be positive 1. Remember, we just talked about this. These numbers right here have to have the same sign. 3x squared and 1x is going to be 1x. And negative 6x and negative 2 is going to be negative 2. And these numbers here have to have the same sign also. So that gives me x minus 2 and 3x plus 1 equals 0. So then we take each one of these factors and make them equal 0. So x minus 2 equals 0 and 3x plus 1 equals 0. Add 2 to both sides. X equals 2. Subtract 1 from both sides. 3x equals negative 1. Divide by 3. And x equals negative 1 over 3, or negative 1/3. I've got two answers again. Remember, you've got to have two answers. You can check your two answers by taking them and plugging back into x. And when I plug them back in for x, this time it should equal 2. Or I can come to this equation here, plug them back in, and make sure that it equals 0. But please make sure that you have two answers when you're finished with the problem. We haven't really added anything new here. This is just taking tic-tac-toe, and then instead of stopping once you factor it, you have to go one step further and actually solve for x, which is something that we should all be able to do.